back to things. Okay, so what options do we have here on this date object? To JS date, to JSON, to local, to object, to relative. Returns a string representation of the time relative to now, such as in 2 days. Neat. To local, set the date time zone to the host's local zone. Nope. So to ISO time. ISO date. To ISO. To format. Set zone. By default, the setter keeps the underlying time the same. New instance will report different local times including DSD when making computations. Reconfigure. Offset, and we have a bunch of things to interrogate. So like we can see the zone. That's interesting. So if I do that, system zone, okay. Name. Interesting. Why? Right, so date here, passed in from ISO. So why not? Okay, so when I run from ISO, it okay. So there's an option called zone for from ISO. Use the zone if no offset is specified in the input string. Will also convert the time to this zone. Defaults to local. Override the zone with fixed offset. Specify the string itself. If specified, defaults false. Huh. So wait. Is set zone a boolean? True. I will say, hey, look, UTC -4. I will say I've not used Luxon, I think, ever prior to the last stream. Actually, we didn't have it imported last stream, like installed last stream. So I guess, yeah, I don't think I've come across it a couple times, and it looked like a good option. It was like, when thinking about a library for this project, like, oh, I'll go find that. And looking through the docs seemed reasonable, so here we are. So if I do date to ISO date and I run this, hey, we have the right date. Now, to get the actual start time, we need to do something fun here where we take the date from I guess I have to take the date and convert it to the time zone present in the plan, and then set the time to that start time, and then convert it back to the zone originally present in the date. Okay. Time zone. Is that accurate? Huh. Okay. Console log that. Does that actually work? Yes, UTC -4. All right, cool. So, then, well, let's see what Copilot generates here. So it's thinking convert the start time to the target time zone. So we get date time from ISO, plan.start time, and plan time zone. See, this doesn't work because start time is not a date time, it's just the time. So it's not an ISO 8601 value or a compatible value. So that won't work. I could do something slightly different where I build this by doing plan dot. No, that doesn't work. No. Well, I mean, sort of, but I think we can do this in a better way. So, what I want to do is that I'm going to convert date to the time zone of the plan. Okay, so that's the date in the plan time zone. Set the time to the start time of the plan. Yeah. No. Const date time in plan time zone. So date in plan time zone dot set. That sort of works. I mean, if I'm gonna do that, I might as well do that instead. What aren't you happy with? Hours? I see. Is it hour and minute? Okay. Okay, so date time in plan time zone is the time the stream would start on the day in question in the time zone of the plan. And then you know, this gets simpler. Yeah, I don't think, no, we do need target time zone. So convert to the target time zone. So now date is date time in plan time zone dot set time zone target time zone. Suddenly, it's confused. All right. Yeah. Final date. That confused it. Target time zone, string or null is not assignable. Right, so zone name can be null. That should be an error. Nope. Target time zone is null. There you go. Just bail out if it's null. All right, and then we have final date. And so final date.to ISO date, and then time to format. And then if I run the test, it passes. We have some console log here from before. Okay, cool. All right. Now, is this right? First of all, let's change. Let's say should what? Should return an event in the correct time zone when the event is on the same when the plan is in a different time zone, roughly. Okay, let's make a little bit of room So yeah, that. I mean, first of all, kind of obviously, I want to change the name of the test to reflect what we're testing, right? Because we had just started, I had Copilot generate some things, but I'm also hoping by giving this description, maybe Copilot will I want a simpler test. Let's see. Actually, it should return an event in the correct time zone. The plan is in a different time zone. What am I really trying to say here? The nuance here is that the time is late enough in the day that by being far enough away from the time zone of the plan was scheduled in, it is actually on the day in question. For yesterday, plan is in an earlier time zone is closer to the truth. Yeah. Okay. Yeah, something like that. So if I run this, fails. Why does it fail? Because it's wrong. Fifth. It's actually good. Why did it fail? So start and end date 25th. This is the 25th. This is how I expect that the date will be generated. Technically, this is going to be wrong. I should update this. Okay. This will be right because this will actually be on the 24th, even though when it's generated on the calendar, it'll be the 25th. The recurrence needs to take into account the source time zone and not the target one. Weekly Monday, interval 1, 2300 to 2330. So why is the time 0 instead of 23? What did we do? Yeah, sure. Let's see all that. And run the test. All right, so target time zone UTC -8 checks out. Date in plan time zone. That should be the same thing as what was originally supplied, right? 11:25 midnight -8 UTC -8. Date time and plan time zone. So now that's 2300. This is the start time, 2300. And then final date, we adjusted it back to the target time zone, which is the same. So it's the same. Oh, right. So this format is the wrong format. returns a string representation of the daytime format according to the format string. Yeah, it is what I want. Is it lowercase h? No. I'm confused. Can we look at docs? May I have documentation, please? All right, that opened. In a different. This is going to be bright. It doesn't default to dark mode. All right. So HH 24-hour time padded to 2. That should be right. So why isn't it right? Let's rerun this again. Yeah, 2300. Oh. I should remember which one is expected and which one is actual. The issue is the test is run. Ta-da! All right. Okay, so this seems good. So this kind of exercises the logic around transforming the output to show up correctly. Here's a problem though. No, this is fine. No, this is fine, right? Because we're saying we're on the 25th, right? And we're getting events that are on the 25th. That is ultimately, so I think there is an opposite example, right? Where we, let's see, what do we do this? Maybe Copilot will read my mind and write the test for me that I'm thinking of. Should not return an event per day. Plan is in a later time zone. Something like that. Okay. So it checks to see that the event's the 0. The date is the 25th on the west coast of the US. The scheduled start time is on the 26th. I mean, this is just wrong. Actually, this would be... This is not really an interesting example, but I can turn it into an interesting example, right? So, to see this is kind of the opposite, where, okay, the time zone is East Coast, so that's like UTC minus 5. For this to be, like, if we wanted to make this work where it actually would have items, this would need to be like 2 a.m. to whatever time, it doesn't matter. So that's Monday. But if this is the 26th, it's actually Tuesday with respect to this time zone. So this test will fail and should fail. Yes. What we want to do here is we want to move this to, if I make it 3 a.m. start, it still passes. Interesting. I mean, I guess technically... Oh, right. Right. Okay, so we're not doing the filtering logic yet, right? So, that's good. I guess, like, more than half an hour ago, I said effectively we're doing red-green refactor, and I guess that's what we're doing. So we have a failing test case because 3 a.m. Eastern time in the US is midnight on the West Coast. So that is still the 26th. Wait, what am I trying to say? Hold on. Again, time zones sometimes hard to wrap my head around the implications here. So we're asking is there an event in this list that happens on the 25th with respect to the West Coast? And so 3 a.m. on the East Coast is midnight on the West Coast on the 26th, so it's not the 25th. So this should be 0. I think this is like literally an edge case. Like we're butting up against the edge of the day. There. Like if we change this to 2 a.m., then there should be one event. The reason there are multiple events is because we've not implemented filtering yet. So let's do that. Also, why is this complaining? String or null is not assignable to string. One of these things. Apparently, it can return null. Let's do this. Oh no, I need. Okay, let's do this. Event date equals that, const event time equals that. Why am I doing this? Well, what I'm going to do is I'm going to add a check. Like so. All right. So then we don't have any more type error stuff going on. All right. So now, very long ago, more than an hour ago, I was talking about doing these checks here. And I think we can start doing that. Okay, so basically all the checks we're going to do in the filter are going to be based around the time zone of the plan, right? So like if it's UTC minus 5, then the start date will be based on that. Can we let's see, output test results? There we go. Okay, so in this example, we have plan start date. Plan start date is 26th, and that's set to be the time zone, planned time zone, which is UTC minus 5 effectively in this example. So that's right. So the start date is that, and then the end date let's just console log both of these and rerun the test so we can see that output. Of course it fails. So there we go. So we have the beginning of the 26th to the end of the 26th in the appropriate time zone. Great. So the question is, is let's say checked if the start date is after the target date. So, is this a valid check? I mean, I don't know if the comparison operator is going to work here. I guess we're going to find out. Date here is the provided date, end of day. Um, or yeah, I think this is fine. So this doesn't get us to the resolution of, right? We don't want to consider the start time and end time. Like if the start date, no. Actually, I'm not sure. Let's just do this for now. And reject if the end date is before the target date. Now, here's a question. Does that work? It doesn't not work. Should it have made the test pass? Let's add some console logs here. There's some, yeah. Something like that. Date start of day. So we're seeing all the values that we're dealing with there. It might be worthwhile actually to set breakpoints and kind of step through things. Hey, Death Row. How's it going? How's your Sunday morning been going so far? All right, so we have start date and end date. Chilling, nice. I'm over here trying to deal with time zones, and it's awful. So we have start date and end date. Oh, these are poorly chosen names for these values because I have start date, end date, date start, and date end. But anyway, this is just for logging, for figuring out what's going on in the moment. So yes, I can see why. Right, so like when we're checking to see is start date greater than end of day of the date in question, right? So start date is this value, which is midnight on the 26th. UTC minus 5. Actually, it might be easiest here for logging to like convert everything into UTC so we can see absolute values, because otherwise we have to do this math in our head, right? Of like the date end is the 25th, but minus 8, right? So you add 3 hours onto that and you end up on the 26th at like almost 3 a.m., which is larger than this value. So that, wait. Okay, time to look at the Luxon library and see how we use it. Math. Diffs, shift to. So you can compare. Comparing date times. Date time implements value of to return the epoch timestamp, so you can compare date times with less than, greater than, less than, equal to, greater than, equal to. Be aware that triple equals compares object identity, which is not useful. Use equals to compare. T1 dot has same year or day. Note that these are checking against the calendar. Right. Oh no, it doesn't update the identity. It compares the object identity, right? But that object identity doesn't relate to the actual underlying date value, right? It's just the object that contains the date object. You need to use the equals method. To compare, if you're only interested in checking the equality of the timestamps, you can use two nullies. Yeah. I'm surprised this is not a link. It's kind of unfortunate. So like the comparison I'm doing here is this less than end of day, so date end. Oh yeah. Is this less than this? Well, yeah, they're very close to each other, but they're 3 hours different, right? So this is actually in the same time zone. This would be 3 hours later. So this should actually be less than this. So it's not greater than. So we don't return false here. Should it be? What are we trying to do again? Okay. This is the thing with time zones. It's like just gotta go back and think about like what are we trying to do? What makes sense? So what I'm trying to do is just do some initial filtering of things, right? So we have a list of plans. So this is like, think of like scheduled meetings. Think of like, here's a recurring event series, right? And I'm not even at the recurrent step yet. I just want to say the series of events has defined start and end dates in this time zone. And every time it occurs, it happens, it starts at this time and ends at this time, again, relative to the time zone of that plan. So what I want to ask is actually, I think I have to be more specific here. I have to add the time to the start date. So what we're gonna do is we're gonna break some things. Dot add. Is there an add? What methods do we have here? Plus. What did I do? I already did this once. How did I do that? Oh, I set hour and minute. Let's see. Okay, I could do something like that. I imagine at some point there will be refactoring happening here. So we're gonna do start hour, start minute, and then we're gonna do set like that. So that gets me the start date. So this basically represents the first occurrence, the date and time of the first occurrence of the series that's possible. Yeah. There's more refinement. Like we're gonna have to add a bunch of other checks here to handle like recurrence. But this is the earliest that an event from a plan could happen. So if this start date time is less than start of that day, the start date is after the target date. Wait, no. Right. So if the day that we're trying to, okay, so a little bit of context, because otherwise it's not going to make sense, right? So we have a calendar. We have a calendar, and basically the code is saying for each day, like it's considering the 4th of November, and it's going to say, hey, is there any recurring things happening on the 4th? Then it says, okay, well, I have the list of all the stream plans. I have the date, which is November 4th. Then are there any plans that don't even start by the 4th? That's what this check is. If the start date of the plan is after the target date. Ooh, actually, let's target date. There you go. There's a naming tip, right? Is that if as you kind of talk through the process, you start describing things, and it's like, oh, you refer to it as something. Maybe that's an opportunity to go back and refactor and rename a variable or a parameter. Okay. So then we're going to do the same thing here. We're going to do end date time from ISO plan.endDate in the plan time zone. And then we need a little bit more logic here. To const end hour, end minute. There we go. So this is the point in time at the last possible date of the recurring series at the end of at the end time of that event. So if the end date of the plan is before the target date. Actually, hold on. The end date of the plan is before the target date. So if the recurring series ends before the date that we're currently targeting, then return false. Otherwise, for now, we return true. There's a bunch of other conditions that we have to add around recurrence and skips. But this also gets us a bunch of converted values that we can use for those things. So does that make the test pass? It does. Do all the tests still pass? All 3? They do. Hooray. That makes me really happy. Okay, so this is fun. Okay. So what else is there to do? Reject if the plan is skipped on the target date. Okay, Copilot knows where I'm going with this. That's not going to work. Why is that not going to work? So plan.skips is an array, and we can say, so the sum method evaluates the function against every element of the array. And if any invocation of the function, so if any of the elements in the array, the function returns true, then sum returns true, right? So if sum returns true, then we return false. So on the surface, this looks correct. The comparison is wrong. Specifically, skip.date has to be converted into a value. It needs to be converted into a date time in the planned time zone. And then we basically need to ask if target date and the converted skip date are the same day. I just saw something in the docs about doing that, but we need to do some things. Okay, so const skip date, datetime.frontMISO, skip date, plan zone, plan time zone. Okay, so this gets us, this should effectively be midnight on the date in the time zone that we care about, the plan time zone. And there we go. So the skip date have the same day as the target date. But there's a problem. And the problem is I didn't write a test. So let's write a test that exercises the skips. It should not return an event if the target date is skipped. There we go. Let's make a test, and this test should fail. Yeah, there you go. And then there and there. So is this a good test? So again, we're using the 25th, which is tomorrow. Actually, let's use a real example, right? So at least for me, at least for the US, the 28th, 28th is Thanksgiving, and maybe that's a day that I want to skip, right? So let's make this a little bit broader. Let's say that our series goes from the 1st to the 30th, but I want to skip the 28th. One of the things I'm trying to do as I design or as I fix these test cases is I want to make sure that even once all of the logic is implemented, the recurrences and the dates and all of this stuff will still be valid. So that all of the like previous tests and new tasks, like unrelated code changes, implementing new features that are getting towards kind of where I'm going, I won't have to go back and fix things, hopefully. So if I'm having a weekly recurrence, the 28th is a Thursday. And we're gonna just use my time zone, and we'll just do something a little different. So let's say I had a 18 to 20, 2100 hour, so 6 to 9, which is kind of typical, although I don't normally stream on Thursdays. And then, so if I run this, this should fail, right? Because we have not yet implemented skips. So now, if I uncomment this and I run this again, it passes. All right. I didn't have to do it in that order. Like I could have kept this code and then written a test and make sure it passed. But if I did that, I would probably want to go back and comment out the code and run it again and make sure the test failed. Because otherwise, it's not very strong evidence, right, that things are working the way you intend, because maybe the test isn't testing things. Like maybe that something else was wrong with the data and was making it so that it wasn't generating, like unrelated to the skip stuff, right? So that's kind of the rationale behind like the TDD style red-green refactor of like giving you a pattern to work in that is preventing you from fooling yourself, thinking you're writing tests that are testing things. Um, but the principle is the important thing, not the specific mechanics, but it's definitely helpful for those that just as a structure. If you if you're kind of maybe newer to doing more to writing a lot of tests, I guess. I don't know what I'm trying to say anymore. All right. Copilot, tell me what I need to do next. Okay, rejected the plan does not recur on the target day. That might be true. That might be the next thing to do. Let's see. Let's go up to our interface here. So we're handling start date, end date, start time, end time, time zone, skips. I guess recurrence is the last thing. So I think what we can do is that we can say so recurrence type could be none, or I can just do it that way. Maybe I'll do it that way. Just have a null there. What does that mean, though? I don't think that is actually a meaningful, that doesn't mean anything, right? Because this would just be another way of saying, because this is not an event, this is a plan. So if there's not a recurrence, what does that actually mean? That means it doesn't happen at all. So really what that might have indicated is actually more like a daily recurrence type, and I'm not implementing that yet. So I think the first thing I want to do is I want to say if plan.recurrence type is not weekly, we just throw an error. We just exclude that as a possibility for now. So validate recurrence type. So what is, weekday long is possibly null. So what is weekday long? Get the human readable long weekday, such as Monday. Defaults to the system's locale. Okay, so I think what I want to do instead is I want to have something that's more like weekday is a number, 1 through 7. And then recurrence days, something like that. And I'm going to create this constant here. It's a record from number. I guess technically I can do that. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Doing this as an object rather than an array is kind of nice, in that I can just do this out of order. And that means, so that's translating the weekday of the target date. Target date again being the date with respect to, so this then falls down. So what we need to look at is the target date in the time zone of the plan. Date in plan time zone. Need that. And so we have more copy paste, which means at some point I will go back and want to refactor things. Target date, almost certainly. Target date and plan time zone. Right. So then target date and plan time zone dot weekday. So if the recurrence days don't include this day of the week, then we return false. So I think I've yet again implemented something where I don't have a test for it. Let's do it the opposite direction, right? So we'll do it should not return an event if the target date is not in the recurrence. Sure. We're doing a lot of negative tests, I think, here, right? So let's see. Does this work? So we're talking about the 28th Pacific time. We have an event, also Pacific time, from 6 to 9 p.m. weekly on Monday. But the 28th is not a Monday. The 28th is a Thursday. So this should fail, or it should actually pass right now because I wrote code. All right, but why does it pass because of the code I just wrote? Seems like it fails now, right? So the check we just added had an effect on the behavior of the function. Great. Okay. So what's left? Well, the other consideration is that although I suspect I'm not really going to use this feature, the recurrence does support an interval, right? So not just that the target date happens on one of the recurrence days, but also that if it's like every 2 weeks, it should reject it if it doesn't meet the pattern of the recurrence, right? Reject if the plan does not recur at the correct interval from the start date, right? So that's part of what I'm going to want here, is that it's not simply going to be, it needs to be well, first of all, if recurrence interval is 1, then the existing code will work as is. It's going to be if, say, recurrence interval is 2, that'll be a little different, right? So let's try to write a test for this. It should not return an event if the target date falls on a date on a week that does not avoid that does not match the recurrence interval. Let's see. So Copilot's given us some code. Let's see if it's okay. So first of all, yeah, it made interval 2. So it's saying every other week on Monday. So first of all, part of this test should be that it should be, and we should be asking about a Monday, right? So like the 25th is a Monday. And then we just want it to be, so if we start on the 1st, I'm looking at a calendar on my other screen. Actually, I could look at the calendar in the app right? So if we start on the first, how are the intervals supposed to work? I guess this is the first Monday, and then it skips this one and takes this one and skips this one. So the 25th shouldn't match the recurrence pattern according to that logic that I've just made up right now. So if I save this and I run this, this should fail, right? Because it does generate an event for that date. Okay, so when we come back from the break, I need to implement the code to reject based on the interval. And then we can actually move on to other things beyond this. So I'll be back in a few minutes with some more of all of this. BRB.